In this video, we're going to find the derivatives of trig functions. So before we do that, let's review from trig that sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. And cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. And do you remember from chapter on limit, the limit of sine x over x as x approaches 0 is 1. We're going to need this to prove the derivative of sine x is cosine x. And what about limit of cosine x minus 1 over x as x approaches 0? Well, you may use your calculator and you will find out that this is equal to 0. Also, instead of that, you could say that limit as h goes to 0 of sine of h over h is 1. So instead of variable x, you could use variable h. It doesn't really matter as long as these three have the same variables. Same thing for this case as well. Now we're going to see the proof of derivative of sine x is cosine x. So if f of x equals sine x, what is the derivative of sine x? Well, let's use a definition of derivative. Remember definition of derivative? F prime of x is limit of f of x plus h minus f of x all over h as h goes to 0. Now, since our f of x is sine x, this part will be sine of x plus h minus our f of x, which is sine x. And what is sine of x plus h? Well, it's going to be from trig, this is h goes to 0. It's going to be sine x cosine h plus cosine x sine h. And then you got minus sine x all over h. Now, look at these two terms here. They have a common factor, which is sine x. So I'm going to take out sine x. So you get cosine h minus 1, and then plus cosine x sine h all over h. Now I could separate these two. They have a denominator of h, so I'm going to rewrite it as limit as h goes to 0. It's going to be sine x times cosine h minus 1 over h plus cosine of x times sine h over h. Now what happens as limit as h goes to 0? Well, this one goes to 1. I'm sorry, 0. We talked about it earlier. That goes to 0, and this one goes to 1. So 0 times sine x will be 0, and cosine x times 1 is cosine x. So therefore, the derivative of sine x is cosine x. Now, if you want to find the derivative of cosine x, you could use a similar reasoning, and you will end up getting that derivative of cosine x is negative sine x. So now we know that the derivative of sine x is cosine x, and derivative of cosine x is negative sine x. And let's do some examples. So let's say you have y equals x squared times sine x. How do you find the derivative? Well, it looks like we have to use a product rule, but these two functions are connected by multiplication. So it's going to be x squared times the derivative of sine x, which is cosine x, plus sine x times the derivative of x squared, which is 2x. Now, it's always better to put the polynomial in front of trig function. So let's rewrite it as x squared cosine x plus 2x sine x. So that will be your final answer. So let's say you have u equals cosine x over 1 minus sine x. Now we want to find u prime. In this case, u prime is the same thing as du over dx. You're taking the derivative of u with respect to x. So this is the same thing. For this one, we have to use a quotient rule. So we have to square the denominator. And it will be denominator, which is 1 minus sine x, times the derivative of cosine x, which is negative sine x, minus the numerator, which is cosine x, times the derivative of denominator. So what's the derivative of 1 minus sine x? Derivative of 1 is 0, and derivative of sine x is cosine x, but you have a negative 1. So it will be negative cosine x. So let's distribute. You get negative sine x plus sine square x plus cosine square x all over quantity 1 minus sine x squared. Now, do you remember from trig, what is sine square x plus cosine square x? It's 1. So you get 1 minus sine x over quantity 1 minus sine x squared. Now, this means on the denominator, you have 1 minus sine x times 1 minus sine x, so this will cancel out. You end up getting 1 over 1 minus sine x. So that will be your final answer. Let's say s equals 5 cosine t. This is letter S. And it represents a position of a weight hanging from a spring. And if they ask you to find the velocity is the derivative of position. So what will be the derivative of this? It's going to be 5 times the derivative of cosine t, which is negative sine t. And that's going to be negative 5 sine t. That will be the velocity. What about acceleration? Well, acceleration is the second derivative of position or the derivative of velocity. So what is the derivative of velocity? It's going to be negative 5 times the derivative of sine t, which is cosine t. Now, let's say y equals tangent x. How would you find the derivative of tangent x? Well, let's rewrite tangent x as sine x over cosine x. Now, let's take the derivative. So we have to use a quotient rule. So denominator square, and takes the denominator times the derivative of numerator, which is cosine x, minus the numerator times the derivative of denominator, which is negative sine x. So what do you get? You get cosine square x plus sine square x over cosine square x. And you know that from trig, that's 1. It's 1 over cosine square x. And what is 1 over cosine square x? That is secant square x. So we could say that the derivative of tangent x is secant square x. So we have derivative of tangent x equals secant square x. What about derivative of secant x? Using the similar method, change secant x to 1 over cosine x, apply the quotient rule, and you end up getting secant x tangent x. Now, what about derivative of cotangent x? Derivative of cotangent x is negative cosecant square x, and derivative of cosecant x is negative cosecant x and cotangent x. So it's good to memorize these 6 formulas here so that you save time when you take the derivatives. But just notice that whenever you take the derivative of trig function that start with the c, for example, cosine x, cotangent x, and cosecant x, you will end up having negative. Derivative of trig function that does not start with c, you don't have negative in front of it. So that's one tip that I could give you. Let's say you got f of x equals tangent x over x, and you want to find the equation of the tangent line at x equals 2. In order to do that, we need to find the slope of f at 2. In other words, we got to find f prime of 2, because that would be the slope at x equals 2. And what is the y value when x equals 2? When x equals 2, the y value is tangent of 2 over 2. And when you put that into a calculator, make sure you're in a radian mode. So let's find f prime of 2 to find the slope. We got to find the derivative. And it looks like we have to use a quotient rule. So denominator square, denominator times the derivative of numerator, which is secant square x, minus the numerator times the derivative of denominator, which is going to be just 1. So now what you got to do is you have to plug in 2 for x. Into your calculator. And you get approximately 3.433. Okay, you get a decimal. So this is your slope, and you have a point. So what would be the equation of the tangent line? Be y minus, well, you could change that to decimals if you want. Let me just leave it as tangent 2 over 2 equals 3.433 times x minus 2. So that will be the equation of the tangent line. Now what if they ask you to find the equation of the normal line at x equals 2? Well, the slope of a normal line will be negative reciprocal of a slope of a tangent line. So it will be negative 1 over 3.433. And then you use the same point and get the equation of the normal line.